Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture. And in this video lecture, we will study the problem on resolution of force along the given direction. The problem is find the resolved part of a force equal to 60 kilogram weight. So force given is 60 kilogram weight. Say F is 60 kilogram weight. Fine. Find resolved part of a force equal to 60 kilogram weight in a direction making an angle tan inverse. The angle it making is say theta is equal to tan inverse 3 by 4. So tan theta will be 3 by 4. So here we are. Let us take this is the direction, say R, and this with this direction it is making an angle theta. So we know component this R, or we can also represent it with F. We can also represent it as a F because it is given in the question. It is given in the question. So this R is represented as a F is equal to 60 kilogram weight. So we have to find the resolved part of this force in a direction making an angle tan inverse 3 by 4. So tan theta is 3 by 4. We know that if this is force and this is theta, so resolved part of the force along the direction with which it is making an angle theta is given by F cos theta. So say this is A, this is B, this is C. So we will write resolved part of F along AB is equal to F cos theta. So if tan theta is this one, so what will be cos theta? So let us draw a triangle, right angle triangle. Fine. This is the right angle triangle. This is angle theta. This is angle pi by 2. So you could name this triangle as R S T. Fine. So tan theta is given as 3 by 4. So this will be 3, this will be 4. So this will be 4 square plus 3 square is equal to 25 is equal to 5. So what will be cos theta? You know cos theta is base upon hypotenuse. Base is 4, hypotenuse is 5. So it will be 4 by 5. So this is cos theta. Cos theta is 4 by 5. Now substitute these values over here. We will get F is 60. Look over here. F is 60 kilogram weight. Cos theta is 4 by 5. So this will go on 12. So this will be 48 and units will be same in which the resultant is given. This implies that resolved part is which resolved part? required. Resolved part is equal to 48 kilogram weight. So this is what we were required to determine. Okay, so now we will move towards the next problem. Statement of the problem goes like, if a force F be resolved into component forces, if one of the component be at right angle to F and equal to root 3F in magnitude, find direction and magnitude of the other component. So let us first draw the figure. Let us say we have this force F. Now it is resolved into two component. It is given that one component is at a right angle to F. So let us draw a line perpendicular to this one. Figure should look realistic. 90 degree means 90 degree. So this angle is 90 degree. Mark it as 90 degree and say this component is F. This is force F. This is P. Component is P. This is given to be equal root 3 F. Fine. Now next is find direction and magnitude of other component. Let us say other component is Q and it is acting in this direction. Okay, and component is Q and say this angle it making is theta. So we have to determine theta and Q. I think question is clear in your mind. So we now find the theta and Q. Now you could name the, this is A, this is C, this is B, this is D. Right. P, resolved part of F, resolved part of F along AD is equal to, now use the formula F resultant as such, sine of the other angle. Now we are talking about the resolved part in this particular direction. So 90 degrees is a primary angle. Other angle is theta. So it will be sine theta divided by sine 90 plus theta. This is equal to F sine theta. Sine 90 plus sine in second quadrant is positive. So this will be cos theta. So this implies that P is equal to F tan theta. But we are given that, you will see, but we are given that this resolved part in the direction of AD is given to be root 3 F. This is given. And name this equation as 1. Using this in 1, using it in 1, we get root 3F, because this will be used over here, this will be root 3F is equal to F tan theta. This F to F will cancel out. Tan theta is equal to root 3, implies theta is 60 degree or pi by 3 in radians. So theta is pi by 3. One thing we have determined. Now we have to find Q. Q is equal to resolved part, right? Its meaning resolved part of F along AB. Resolved part of F along AB is equal to, now use the formula F as such, sine of the other angle. This theta is now primary angle, other angle is now, because we are interested in taking the resolved part along AB. So this theta will become the primary angle, this 90 degrees other angle, so this will be 90 degree. So sine sum of the angles, you write sum of the angles, this will be f. Sine 90 is 1, f theta plus 90 degree second coordinate is cos theta, so this is equal to f by cos theta. F by cos theta is pi by 3. So you know cos 60 degree is 1 by 2. So this will be 2f. So we have determined that component q is equal to 2f and theta is equal to pi by 3. These both things were required to determine. So this is the second question. Now we will take up the third problem, and the statement of the problem is, the statement of the problem is, the resultant of two forces P and Q is R. The resolved part of R in the direction of P is of magnitude Q. Show that the angle between the forces is this one. So let us first take the forces. Say this is force P, direction of force P, and this is force Q, and this is the resultant. Fine. So complete the parallelogram. So this portion is extra. Let me rub this one. And this is resultant R, and say this angle is that it is making with the direction of force P is theta, and angle between the forces is say alpha. Okay, this is angle alpha. Now resolved part, read out in the statement, resolved part of R, you will write all these things. You will write the meaning of alpha. Alpha is angle between P and Q. Theta, you will write resultant making an angle with the direction of P. You will write the forces P and Q. You could write, name them, this point A, this point B, this point C, this point D, acting in the direction, resultant in the direction AD, P is in the direction OB, Q. You will write all these things as a preliminary thing. Okay. Now, as given in the question, resolved part of R in the direction of P is of magnitude Q. So if I write Q is equal to resolved part of R in the direction of P, that is along AB direction. Fine, we know that if this angle is given to be theta, then resolved part of R along this direction will be nothing but R cos theta. So this will be resolved part of this r along this direction will be r cos theta, and this in magnitude wise, in magnitude means its size of the line that this resolved part of r will contain is of magnitude q. So what will be this size of the line? It is a kind of projection. If you will project this over here, then in along AB, if you project projection of AD along AB will give the magnitude, and this projection will be like this one. Say I am going to project this and draw the perpendicular, and this will be further extended, okay, and this is the perpendicular, say 90 degree. So this is the length of the resolved part, or in turn I say this is the magnitude r cos theta. So along AB, and if I name it as E, so what will be this magnitude? You know, this is force Q. Fine, this is force Q. So if I write this projection will be the A. So this thing, if I write further, is r cos theta is equal to A, and you know A is further equal to AB plus B. AB from here is very much clear that this thing up to here is P, force P. So this will be P, and B is base, because if you see, if this angle is alpha, this will also be alpha, okay, fine. So this angle will also be alpha. So in right angle triangle B D E, B upon BD is equal to cos alpha. You see, this is BE and this is BD. This angle is alpha, this is 90. So this is hypotenuse, this is base. Base upon hypotenuse is cos alpha. So BE by BD. So here can I write it as BE upon BD dot BD. From this thing is equal to cos alpha. So this will be P plus cos alpha, and BD over here you can see is Q, So this is Q. So this implies that Q, because here this magnitude is given to be Q, the resolved part of R in the direction of P is given to be Q. So this is equal to P plus Q cos alpha. So this implies that Q minus Q cos alpha is equal to P, implies Q 1 minus cos alpha is equal to P, implies Q, use the formula 2 sin square alpha by 2 is equal to P. This implies that sin square alpha by 2 is equal to P by 2Q. Taking square root on both sides, sin alpha by 2 is equal to P by 2Q. The square root implies alpha by 2 sin inverse. Taking sin inverse on both sides, it will give P by 2Q. This implies that alpha is equal to 2 sin inverse root P by to Q. Hence, we have determined angle between the forces is P sine inverse root P by 2 Q. This was required to prove that this angle is this much. So, this question you can mark is very important from examination point of view. So, in this article we have covered 3 important problems based upon the resolution of the forces, and I hope that you will be able to understand the concept and the idea used in these problems, and that is the last lecture on the resolution of the forces. Now you will try the exercise questions, and if you have any problem you will drop the problem in the comment section. I will definitely respond to your queries. So that is all I have from this lecture, and if you have liked the lecture I would request you to just like, subscribe, share and comment. This is Dr. Rajesh saying a goodbye, take care, bye bye, and see you soon. Thank you very much.